Hello everyone, my name is Vanessa Lagos and today I'm going to talk about the nutritional value of palm kernel products fed to pigs. This is the outline of this presentation. I will talk about the global production of palm kernel products, then I will compare the nutrient composition of these products with other two oilseed meals. I will show data about the digestibility of energy, amino acid, and phosphorus. Then I will talk about growth performance experiments, some approaches to improve the nutritional value of these products, and by the end I will give you some conclusions. This graph shows the global production of palm kernel products in millions of metric tons. Palm kernel expeller and palm kernel meal production has increased linearly from 2005 through 2017. Let's compare the nutrient composition of these two products with other common oilseed meals. In these graphs, the y-axis represents the concentration of gross energy, crude protein, acid hydrolyzed ether extract, and ash. In copra meal, as light blue bar, palm kernel expeller as dark blue bar, palm kernel meal as yellow bar, and soybean meal as orange bar. The concentration of gross energy is similar among ingredients, but the concentration of crude protein, as expected, is greater in soybean meal than in other oilseed meals. The concentration of fat is greater in palm kernel expeller as a consequence of the mechanical extraction, and in terms of ash, there are similar values among ingredients. So far, the nutrient composition of palm kernel expeller and palm kernel meal is comparable with other oilseed meals. However, if we take a look at the fiber composition, palm kernel products have a concentration of NDF, TDF, and IDF that is greater than 60%. This will be a limitation for pigs because fiber will increase the passage rate and the digestibility of nutrients and growth performance will decrease. In general, these products vary considerably in nutrient composition, protein, fiber, and lipids depending on the palm sources, the methodology of oil removal, and the proportion of shells remaining in the product. So why would we use these products with such a nutritional disadvantage? If we compare palm kernel meal and soybean meal in terms of quality, soybean meal has greater protein and lower fiber than palm kernel meal. But if we take a look at the price, soybean meal is 2x more expensive than palm kernel expeller and 3 times more expensive than palm kernel meal. Therefore, if we use these two products combined in diets, we can equilibrate quality and price. Now, let's move into the digestibility of energy. In 1999, Agunviade and colleagues conducted an experiment to determine the digestible energy and metabolizable energy in palm kernel expeller. The authors in the paper called the product palm kernel meal, but based on the value for fat, it is actually palm kernel expeller. They used 3 different inclusion rates, 5.8, 11.7, and 17.5% of palm kernel expeller. In this graph, the bars became darker as the inclusion rate increases. They did not find a linear response in the DE and ME values as the inclusion rate increased, but they did find differences among inclusion rates. Therefore, the authors concluded that in order to get accurate values of DE and ME in this product, it is necessary to use more than one inclusion rate. The average for DE obtained in this experiment was 3,147 kcal per kilogram, and for ME, 3,091 kcal per kilogram. In 2012, Son and collaborators conducted an experiment to determine the DE and ME in copra meal, palm kernel expeller, and cassava rod. They found a negative correlation between the digestibility of energy and the concentration of NDF. They also found that there is no difference in the DE and ME between copra meal and palm kernel expeller. However, the values in this experiment are greater than the ones obtained in the previous experiment. In 2013, Sulavo and colleagues used a basal diet with 96% of corn and 5 diets with 70% basal diet and 30% copra meal, palm kernel expeller from Indonesia, palm kernel expeller from Costa Rica, palm kernel meal, and soybean meal. They found that the DE of palm kernel products is lower than in corn and soybean meal, and the same pattern was observed in ME. However, these values are lower than the ones obtained in the previous two experiments, even though the values for DE and ME in corn and soybean meal in this experiment are greater than in the NRC 2012. In summary, for the energy, there is variability in the concentration of DE and ME among sources of palm kernel products. However, palm kernel expeller has a greater ME and DE values than palm kernel meal, probably due to the high concentration of fat and lower concentration of fiber in palm kernel expeller. Now let's talk about the amino acid digestibility. This graph shows the composition of amino acids in oilseed meals, copra meal, palm kernel expeller, and palm kernel meal. I did not include soybean meal in this graph because the values are not comparable, and let's see why. The concentration of lysine in palm kernel products is 0.37 versus 3% in soybean meal. For methionine, the concentration in palm kernel products is 0.24 versus 0.7 in soybean meal. For threonine, 0.35 versus 1.7 in soybean meal. And for tryptophan, 0.09 versus 0.6 in soybean meal. So let's analyze this in a different perspective. The lysine to CP ratio in palm kernel products is lower than in soybean meal, and this is probably due to Maillard reactions that are initiated during drying of these products. The tryptophan to CP ratio is also low compared with soybean meal, but the methionine to lysine ratio is greater in palm kernel products than in soybean meal. This means that palm kernel products are complementary to soy protein. The arginine to lysine ratio is also greater in palm kernel products than in soybean meal, and this could be a limitation because arginine and lysine compete for the same transporter in the enterocytes. So if arginine is high in concentration, the absorption of lysine can be reduced. Therefore, it is important to supply lysine in these diets. In terms of the standardized ileal digestibility of amino acids, Fevrier and colleagues in 2001 conducted an experiment to compare the digestibility of amino acids among 3 sources of palm kernel meal. They found a negative correlation between the SID of lysine and the concentration of NDF, and this can be explained by 2 facts. First one, that fiber increases the specific endogenous losses of amino acids, and second, that non-starch polysaccharides can trap some proteins and therefore proteases are not able to degrade protein, so the digestibility of amino acids will be reduced. In this paper, no SEM and p-value were provided, but we can see in the bars that there are differences among sources of palm kernel meal. Sulavo and colleagues in 2013 conducted an experiment to determine the SID of amino acids in copra meal, palm kernel expeller from Indonesia, palm kernel expeller from Costa Rica, palm kernel meal, and soybean meal. They found that the digestibility of lysine, methionine, and threonine is lower in one source of palm kernel expeller and palm kernel meal than in soybean meal, but no differences with copra meal. For tryptophan, the digestibility is lower in palm kernel meal than in soybean meal. In general, these values are greater than the ones obtained in the previous experiment. In 2014, Son and collaborators conducted an experiment to compare the SID of amino acids between copra expeller and palm kernel expeller. They found a really low digestibility of lysine, probably due to heat damage during drying. In terms of methionine, threonine, and tryptophan, the digestibility was greater in copra expeller than in palm kernel expeller. The values obtained in this experiment for palm kernel expeller are in agreement with the first experiment, but not with the second experiment. So in summary, for the digestibility of amino acids, there are also variability among sources of palm kernel expeller and palm kernel meal. I was not able to establish which of these byproducts is better or has higher digestibility of amino acids. But what I can say here is that the digestibility of lysine is low, and therefore, in diets where palm kernel products are used, it's important to meet the requirement of digestible lysine. Now, let's talk about the digestibility of phosphorus. But first, let's check the concentration of calcium, phosphorus, and phytate in copra meal, palm kernel expeller, palm kernel meal, and soybean meal. The concentration of calcium is greater in palm kernel expeller than in the other oilseed meals, but the concentration of phosphorus is higher in soybean meal. In terms of the concentration of phytate and phytate-bound phosphorus, the value is greater in palm kernel expeller and soybean meal than in palm kernel meal and copra meal. In 2014, Almaher and colleagues conducted an experiment to determine the standardized total tract digestibility of phosphorus in copra meal, palm kernel expeller from Indonesia, palm kernel expeller from Costa Rica, palm kernel meal, and soybean meal, with and without phytase. They found that the digestibility of phosphorus is greater in palm kernel meal than in palm kernel expeller, and this is due to the high concentration of phytate and phytate-bound phosphorus, because phytate binds phosphorus, making it unavailable for pigs. They also found a negative linear relationship between the digestibility of phosphorus and the concentration of phytate-bound phosphorus. They suggest that using this equation, it is possible to estimate the digestibility of phosphorus in these products only using the concentration of phytate-bound phosphorus. In 2013, Son and collaborators conducted an experiment to compare the digestibility of phosphorus among copra expeller, palm kernel expeller, and cassava rot. They found no differences among ingredients, but the value for palm kernel expeller in this experiment is greater than in the previous experiment. In summary, for phosphorus digestibility, there are also variability among sources of palm kernel expeller and palm kernel meal. However, the digestibility of phosphorus is greater in palm kernel meal than in palm kernel expeller due to the low concentration of phytate. Phytase increases the digestibility of phosphorus in both palm kernel expeller and palm kernel meal. Now, let's talk about some growth performance data. In 2014, Jaworski and colleagues conducted an experiment using weanling pigs to evaluate the effect of palm kernel expeller in growth performance. They used 4 inclusion rates: 0, 5, 10, and 15%. They found a linear decrease in the average daily gain as palm kernel expeller increased from 0 to 15%, but no linear response was observed in the average daily feed intake and gain to feed ratio. Therefore, the authors concluded that it is possible to use palm kernel expeller in weanling pig diets up to 15% depending on the objective of the production. The same authors conducted another experiment using weanling pigs to test the effect of inclusion of palm kernel meal from 0 to 15% in the growth performance. They did not find any differences among diets. Therefore, the authors concluded that it is possible to include palm kernel meal in weanling pig diets up to 15% without negative effect in growth performance. Seo and colleagues in 2015 conducted another experiment with weanling pigs comparing a control diet, a normal corn-soybean diet, and another diet with 20% of palm kernel expeller as a replacement of both corn and soybean meal. They found that the average daily gain and average daily feed intake could be improved by the inclusion of 20% palm kernel expeller. Therefore, the authors concluded that it is possible to include palm kernel expeller in weanling pigs' diets up to 20% without negative effect in growth performance. In terms of growing pigs, Adesenhiwa and colleagues in 2014 conducted an experiment with pigs from 37 to 60 kilograms to evaluate the effect of the replacement of corn by palm kernel expeller in 0, 50, and 100%. The diet with 100% replacement had 30% of palm kernel expeller in the diet. The authors did not find any differences in any of the growth performance parameters, and they found a reduction in the diet cost as corn was replaced by palm kernel expeller. Therefore, the authors concluded that it is possible to include palm kernel expeller up to 30% in growing pig diets without decreasing growth performance. In summary, it is possible to include palm kernel products in weanling pigs diets up to 20% and in growing pig diets up to 30%. Now, let's talk about some approaches to improve the nutritional value of palm kernel products. The nutritional value of palm kernel products can be improved by the addition of enzymes in diets, by enzymatic treatment, and by fermentation treatment. 81% of total carbohydrates in palm kernel expeller and palm kernel meal are non-starch polysaccharides. 66% of those non-starch polysaccharides are mannans. In palm kernel expeller, there is a concentration of 244 grams per kilogram versus 20 and 9 in soybean meal and corn, respectively. Therefore, mannanase can be used as an additive in diets to improve the nutritional value of these products. In 2013, Mock and colleagues conducted an experiment using 4 diets: one diet with no enzymes, a second diet with 1600 units per kilogram of beta-mannanase, a third diet with 1000 FTU of phytase, and a fourth diet with a combination of the two enzymes. They evaluate the effect of the enzymes in the apparent total tract digestibility of energy and phosphorus and the digestibility of amino acids. They found an effect of beta-mannanase in the digestibility of energy and an effect of phytase in the digestibility of phosphorus. In terms of amino acids, they only found an interaction between beta-mannanase and phytase in the apparent ileal digestibility of tryptophan. Therefore, in 2013, Kwon and Kim conducted an experiment to test the hypothesis that inclusion of beta-mannanase will increase the DE and ME value in palm kernel expeller. However, they did not find any differences between treatments. In 2011, Ao and colleagues conducted an experiment to test the effect of a carbohydrase cocktail composed by galactosidase, protease, and beta-mannanase in the growth performance and digestibility of energy and nitrogen in growing pigs. They found a linear increase in the average daily gain and gain to feed ratio in diets with 5% palm kernel meal as the concentration of the carbohydrate cocktail increased from 0 to 0.2%. In terms of the digestibility of nutrients, the same response was observed for energy and nitrogen. Therefore, it is possible to say that inclusion of enzymes in diets is an option to improve the nutritional value of these byproducts, but more research is needed. Enzymatic treatment is another approach to improve the nutritional value of palm kernel products. Enzyme-treated palm kernel expeller has been produced and tested in poultry with success due to the enhanced nutrient composition. The concentration of crude protein is increased and the concentration of fiber is decreased by the enzymatic treatment. However, this has not been proved in pigs, so it is possible to think that it will increase the nutritional value for pigs, but research is needed. Fermentation treatment is another alternative to improve the nutritional value of these products. With fermentation treatment, the concentration of crude protein in palm kernel meal is increased and the concentration of fiber is decreased. We can observe the same for palm kernel expeller, greater concentration of crude protein and amino acids, and lower concentration of fiber. This is another approach to improve the nutritional value for pigs because of the good results in poultry, but no data is available for pigs. So in conclusion, palm kernel products are good alternatives for reducing feeding costs, especially in places where soybean meal and corn is imported and there are access to these byproducts. Palm kernel products can partially replace soybean meal and corn as sources of protein and energy. In weanling pigs can be used up to 20% and if growing pigs up to 30%. However, there are high variability in palm kernel products that need attention. This means that before using these products in diets, it is important to determine the nutritional value. Diets should also be formulated based on metabolizable energy, digestible amino acids, and digestible phosphorus. And there are approaches to improve the quality of palm kernel products, which may also improve the nutritional value for pigs based on the data for poultry. With this, I would like to thank you all for your attention and all people from my lab for their support. And if you want to have more information about these topics or other topics, you can visit our website at nutrition.ansai.illinois.edu.